Everybody, and welcome back. This is the last class in the current module. We're going to look at cube root functions today. So pretty much the exact same thing as the last lesson. It's going to be characteristics, transformations, right equations, and then essential questions, once again, what are the steps? So in the last video, we looked at the property square root functions. We identified the transformations. We wrote equations. We're going to be doing the exact same thing again today, but for cube root functions instead of square root functions. So the cube root function, remember our normal our normal cubic function goes up, turns and goes up again. So it's that S shape. The cube root function is one that has been reflected over that line y equals x. So it's now an S sort of shape on its side. And then center point is that key point, that HK value. And then we've got two reference points as well, which are usually what we will be able to tell the transformations by. And just look at general shape. So the S shape is when there is no reflections happening. If you see that S shape get reversed, you know that there has been a reflection of some sort. All right, so the domain is going to be negative infinity to positive infinity unless something else happens to change it. Same thing with the range. And then end behavior matches what happened in the original x cubed as well. So as x goes towards infinity, y goes towards infinity. As x goes towards negative infinity, y goes towards negative infinity. So there is an end behavior in both directions for this one compared to the square root function, which only had an end behavior in one direction. All right, so transformation, general form, we've got our a value, our b value, hk. It looks the exact same, except notice that there is a cubed root. And just be aware of that it's going to get confusing sometimes, like a cubed versus a cube root, and they won't always be this spread apart. So you want to watch out for that 3 being nestled in against the root, so the radical, compared to being tucked in right on top of that a. So just make sure you're watching out for the difference. You sometimes can get confused between a cubed and then cube root function. And then they all do the exact same thing. So a, vertical stretch compression, b, horizontal stretch compression, hk are the translations, and that kind of center point, it would be a center of rotation or a central symmetry point. That is your hk value. So if we're looking at this one, a value of a half, so we would say a vertical compression by half. H is 2, so we're going to translate right 2, and then plus 6, up 6. That's it. Looking at it in that b value, so this one is minus a third. So if we were just to break that down, that'd be minus 1 over 3. So the b value is 3, but there is a reflection as well. So we want to watch out for that, make sure we're breaking it apart the way we are supposed to. So in this one, we would say reflection, and if the b value is negative, it's a reflection over the y-axis. So reflection of the y-axis, b value is 3, so it's a horizontal stretch. And then we've got a translation, x minus h, so h is 4, so translation right 4, and then k is plus 1, so we're going up 1. Take a shot at it. So here's your two transform functions. Identify the transformations. Pause the video, come back, and see how you did. Okay, so the first one, 3/5. 3/5 is less than 1, so this is a vertical compression. By 3/5. H is -7, so we're going to translate left 7, and then k is -9, so down 9. All right, in the second one, we talked about this in the square root function one. If the b value is not obviously given to you. So in this case, 2 is in the spot of 1 over b. So 1 over b equals 2. You would multiply by b on both sides, and then divide by 2. So we get a half is equal to b, which means that there is a horizontal compression here. Now you may be able to start just kind of recognizing that as time goes on, but I would check it just to make sure, like use your algebra and just make sure that you're working out that b value. H is -5, so we're going to translate left 5 down 3. So I hope at this point that you're like, yeah, transformations, that's easy. Like I can recognize these things, no problem. They're all the same. All the functions are the exact same, even if some part of it is changing. All right, writing the equation. Again, no difference. We know that the h and k values given to us by that central symmetry point. So h equals 4, k equals 2. And then we've got 2 points given to us. We can pick either one. I'm going to do 3, 0. So x equals 3, y equals 0. So 0 is equal to a times that cube root. We said x was 3, h is 4, so minus 4, and then plus k, which is 2. All right, so we've got 0. I guess let's subtract that 2 from both sides. Start working this thing down. So minus 2 is equal to a times the cube root of -1. Now remember, you can do cube roots of negative numbers. So the cube root of -1 is just -1. So minus 2 equals a times -1. Divide by -1 on both sides. A is equal to 2. And we knew we were expecting a positive a value because this does have that classic S shape. So there was no reflection going on here. I wasn't expecting to get a negative a value. So g of x is equal to 2 times the cube root of x minus 4, and then plus 2. Let's do one now where we're solving in for the b value. So we've got h equals 0, k equals 3. I'm going to pick 3, 4. So 4 is equal to cube root of 1 over b. X is 3. H is 0, so it's just going to be 3. And then k is also 3. All right, so we got, subtract the 3 from both sides. 1 is equal to the cube root of 3 over b. So to get rid of the cube root, you're going to have to cube both sides. So cubing and cube roots are the inverse of one another. And then 1 cubed is 1, so we get 3 over b. Multiply by b on both sides because you want to get b out of the denominator. So b times 1 is b. b is equal to 3. So this is going to be g of x equals cube root of 1 over 3, because b is 3, x plus 0, so we don't have to do anything else there. And then we've got k is plus 3. So cube root of 1/3 x plus 3. All right, your turn. Do the two equations in the given format. And that should say cube root, not square root, but you get the idea. So first one, I'll pause the video, come back, see how you did. All right, so first one, we've got h is minus 1. H is minus 1. K is minus 4. X, I'm going to go with minus 2, 0. So we got 0 is equal to a times the cube root of x is minus 2, and then it's going to be minus -1, so plus 1, and then k is minus 4. Add 4 to both sides, so 4 is equal to a times the cube root of minus 1, which is just minus 1, so 4 equals a times minus 1. which means minus 4 is equal to a. So g of x is equal to minus 4 times. So notice I put the times in there just to kind of give that separation from the a value and the cube root part. So it's going to be cube root of x plus 1, and then k is minus 4. Second one, solving for that b value. So we've got h is 5, k is 1, x is 1, y is minus 1. I stick with the smaller numbers typically because they're usually easier to work with rather than 9, 3. But it's up to you. It'll work for either one. So minus 1 is equal to cube root of 1 over b times x is 1, h is 5, so 1 minus 5, and then plus k, k is 1. Okay. So we got minus 1 equals, actually let's subtract that other one from both sides. So minus 2 is equal to, we've got cube root of 1 over b times minus 4. So we're going to do cube on both sides. So minus 2 cubed is minus 8. And inside here, we're going to be left with minus 4 over b. So multiply by b on both sides. So we get minus 8b is equal to negative 4. Divide by negative 8. So those negatives are going to cancel, and 4 divided by 8 is a half, so b is a half. So if I do 1 over a half, that's going to be equal to 2. So in that 1 over b spot, I'm going to put a 2. So final answer, g of x is equal to the cube root of 2 times x minus 5 plus 1. All right, that brings us to the end of today. Nice short video. Essential question, what are the steps to writing a cube root function? Exact same thing, sub in for x, y, h, and k, and then solve for either a or b, whichever one you're being asked for. Make sure you are practicing both, because I will ask you for a specific version as opposed to just write the equation. After today's lesson, complete the module folder. So you've got the cube root functions that you just finished, do the independent practice, then you've got math test, and a checkpoint to finish by the end of the week.